134 must have fallen out.
Oh man.
So you said we're going to 135.
135 we're going to skip for right now. Okay, page 136. Everything we've done so far has been theoretical probability. So if you roll a standard number cube, what's the probability of rolling a 3?
1 out of 6.
1 out of 6, because one side of a normal die is a 3 out of the 6 total sides. And that notation was probability of getting a 3 is 1 out of 6. If you roll a standard number cube 12 times, how many times would we expect to roll a 3? How would you figure that out? Someone other than Weston. Yep, 1 out of 6, because that's our probability of rolling a 3, times 12 is going to give us 2 times. So in theory, if we roll a dice 12 times, we should get a 3 twice. So now we're going to talk about experimental probability. Which, I know this is going to surprise you, is the probability found by conducting an experiment. I know. So we are going to perform that experiment we were just talking about. I'm going to take a regular 6-sided die, and I'm going to roll it 12 times. Sorry. So I'm going to record the outcomes right here. I'm going to roll 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Actually, I'm going to let one of you do this. Who wants to roll this for me? All right, Weston. So roll it and tell me what you get.
1.
Okay.
1. You're not going to believe it.
It's a 1?
It's a 1. I'm actually shaking it too. 4. 4. 5. 5.
This is impressive.
I know. 2. 1.
Dude, why did you just roll your dice?
I know.
Where'd it go?
5.
Okay.
Like there's a pattern here. 4. 6. There we go.
All right.
Finally.
So theoretically, we said we should roll a 3 how many times? 2. But we didn't roll a 3 at all, so we rolled it 0 times. So did they match? No. Is theory always going to actually happen in real life? No. Okay. So to find experimental probability, you take the number of times the event happened during the experiment and divide that by the number of trials. All right. So the table shows the result of choosing one card from a deck of cards, recording the suit, and then replacing the card, not the car. So they pulled pulled 5 hearts, 9 diamonds, 7 clubs, and 5 spades. So example 1, find the experimental probability of choosing a diamond.
So I think we'd actually have to choose a diamond, or like
Conduct the experiment.
conduct the experiment.
Well, what they're wanting us to use these results from this experiment to find the probability that the next card we pick would be a diamond.
Okay, for some reason I was looking at that, I'm like, okay, a deck of cards, there's 9 diamonds.
Right. Okay, so they chose, or there were 9 diamonds, right? They pulled a diamond 9 times out of, how many trials did they have? How could I figure it out?
26 different trials.
How'd you get that? You add them all together.
5 plus 5 plus 9 is 19 plus 7 is 26.
Exactly. So 9 out of 26 is the experimental probability of choosing a diamond. That does not simplify. So there you go. Okay, I don't know if you guys know this, but in a deck of cards, how many diamonds are there? 13. So in theory, they would choose, or the probability of choosing a diamond is 13 out of 52. But our experiment gave us 9 out of 26, right? Find the experimental probability of choosing a card that is not a club. So if it's not a club, what is it?
Well, then anything else. So
Anything else. So it would be
we do 7 over 26, or 26 times 7.
26 minus
over
7.
26.
So the probability of not a club, there were 7 of them that were clubs. 26 minus 7 is 19. So we're going to do 19 out of our total of 26, which does not simplify. You tracking with me so far? Nothing too crazy? Okay, now we're moving on to a different experiment. We have a sack of marbles that have 15 red, 15 blue, and 20 yellow distributed into it. What's the theoretical probability that Gail chooses a red marble? So this is just in theory. There's no experiment. We're not pulling marbles.
So it would be like 15 out of 50.
Yes, so the probability of choosing a red one, there's 15 red out of 15, and 15 is 30 plus 20 is 50. Does that simplify? It does.
I'll do math.
Okay, they're both divisible by 5. 15 divided by 5 is 3.
3 over
If- yep,
10.
10. Okay, now Gail is going to perform the experiment. He pulls 30 marbles, replacing them each time, and records the results as shown below. So he has a bag of marbles, and he's pulled 13 red, 9 blue, and 8 yellow. So what's the experimental probability that the next marble he picks will be red? So I'm going to do the probability of red based on this experiment. 13 out of, how many marbles did he pull?
Well, there's 30.
30.
But how does it compare to the theoretical probability? No, that's the experimental, right?
Okay, this one is experimental because he did the experiment and these were the results. This one was theoretical. So how does 3 over 10 and 13 over 30 compare? Well, in theory,
I was not looking at example number 3. And that's
I know it's a little confusing the way it's worded.
I didn't connect the dots where it's 15 red, 15 blue, 20 yellow.
Okay, so a lot of times probability is easier to think about whenever you're talking about percentages. So if I have 3 over 10 as a decimal is 0.3. What's 0.3 as a percentage? 30%. So in theory, there's a 30% chance of pulling a red. But based on our experiment, we have 13 over 30, which is 0.43 repeating. So about 43%. So how do those compare?
One is 13% higher
Mm-hmm.
than
Okay, in our experiment, he was way more likely to pull out a red than in theory, based on the results of that experiment. So again, they're not always going to be equal because reality does not match theory most of the time. Okay? All right. So now we have our fun part of the lesson. So based on the book, a tribute has a bit more than a 50% chance of advancing to day 2. After the first day, a tribute's chance of advancing from day to day raises to about 85 to 95%. So we're going to create a simulation of a 12-person celebrity Hunger Games. Okay? So in our Hunger Games, we have Justin Bieber, Miss Ulaga, Katniss Everdeen, Harry Potter, Batman, Darth Vader, LeBron James, Miss Hackett. Miss Pendergraft doesn't work here anymore, so we're going to replace her with Miss Lashley. Miss Stewart, Miss Goddard doesn't work here anymore, so we're going to replace her with... Which teacher should we do? Which math teacher?
Miss Ireland.
Miss Ireland.
she's a
Oh, yeah, and she put his winner. Let's go.
Oh yeah, so in this one she won. All right.
she's not just a softball coach, man.
Nice. Okay, so the way this is going to work is up here at the top. We're going to roll 2 dice for each day. So the first time we roll the dice, if we roll an 8, 9, 10, 11, or 12, that person's going to be eliminated. If we roll something other than that, then they're going to survive and they're going to go to day 2.
We're getting rid of Justin Bieber on day 1.
Hopefully. Okay. And then after day 1, so if they survive day 1, if they get one of these numbers and they survive, after that, you continue to roll until you get a 3, 11, or 12. And you, however many times you roll is how many days they survive. Okay. So let's try this together. However many it takes for everyone to die. All right. So we're going to start with Justin Bieber. Day 1. In order for him to be eliminated, I have to roll an 8, 9, 10, 11, or 12.
Oh, yeah.
So I roll a 9. So he only lasted 1 day. Okay, so now we're going to go to Miss Ulaga. I'm going to roll the dice for her. So I roll a 7. So she survives 1 day. So now I need to roll again. After day 1, I need a 3, 11, or 12 for her to die. So she made it through day 1. Day 2, because that's 7, which was not 3, 11, or 12. Day 3. Day 4. 5. 6. 7. 8. She dies on day 9. So you keep rolling those dice until you get a 3, 11, or 12. So for Katniss, day 1, I rolled an 8. So she dies on day 1. Harry Potter, we have a 3, so he survives day 1. 7, day 2. He dies on day 3. So whoever stays alive for the most days wins that Hunger Games. Okay? And then if your final 2 are eliminated on the same day, you're going to re-roll for that day. So like if somebody else gets 9 and that's your biggest number, you would re-roll for day 9 on both of your people to see who lasts the longest. All right. So I'm going to give, since there's not very many of you, I'm going to give you each 2 and you're going to do your own. And we'll probably only have time for 3 of them. But keep going in your own. So you can finish this one. And then do a couple more. So 4 simulations, so 4 trials. So what was my theoretical probability that Nemo would win? Theoretical. Assuming they all have, yep, 1 out of 12, because he's 1 out of our 12 people. 1 out of 12. What was my experimental probability that Nemo would win?
0.
0 out of how many? 4. Because he didn't win any of my 4 trials. What was the theoretical probability that Darth Vader would not win?
11 out of 12.
11 out of 12. What was the experimental probability for me that Darth Vader would not win? Yep, 2 out of 4, because there was only twice when he did not win. So 2 out of 4, which simplifies to 1/2. What was the theoretical probability that a teacher would win? So how many teachers did we have?
5.
So 5 out of 12. What was my experimental probability that a teacher would win?
You had 1 out of 4.
1 out of 4.
What is? Okay, never mind. Answer my question.
And then again, why are theoretical and experimental probabilities not necessarily the same? Exactly. Theory does not always follow reality, or reality does not always follow theory.
That sounds really. It's not.
All right. That is all that we're going to do in the notebook right now. I was going to do our like class district Hunger Games reaping where you put your name in a certain number of times, then we pull out our 2 tributes. But since Emily's gone and Jackson's gone, I'll wait until they come back. We'll do it next week.